Thank you, everyone. I'm Yuanxuan Yang. I'm from University of Leeds, and I'm a research fellow at the Institute for Transport Studies, University of Leeds. And today my presentation is about use new data and the combination of models to support healthy and sustainable urban transport. The slides and materials also include contributions from my colleagues at Leeds, and this is also part of the common project that is sponsored by the Turing Institute. So, people need mobility and transport for access to different activities and services, but how people choose to travel does have wide range of impacts to the urban system, in addition to the transportation system itself. For example, traffic congestions, whether people using public transport or active travel will also has wide-ranging impacts to other sectors such as health, energy, and environment. Luckily, in recent years, there are many new and emerging forms of data being used in research. So researchers and tech companies now have access to many, for example, location-based data, and this data are harvested from people's smartphone or wearable devices with consent. And using this data, combined with novel and hybrid models, it is possible to support better policy making. But there are many challenges in doing this. The data management itself is quite challenging already. For example, especially considering of protecting people's privacy in it. There are also many other challenges in the model interface parts. For example, how to model the demographic, transport, environment, and health models. So in this work, I would like to first introduce the data that we're going to use. So the data is the smartphone track and trace data. The diagram here shows what we can possibly get from a passive tracking app, which is run in the background of people's smartphone. So everything is automatic, helps the users to get the automatic travel logbook. And in the data, we have a lot of information covering mobility contents and individual contexts. So the variables could be a lot of spatial temporal details, the travel modes, speeds, and even the trip purpose could be inferred from the POI data and trajectories. And with this data, we are also able to monitor the changes in people's traveling behaviors. For example, in this study, we provide incentives to people if they choose to use more public transport and active travels and reduce their personal car use. So in that case, it is possible to compare how these kind of incentives have led to some changes in people's travel choices. Also, these kinds of data could also be used for monitoring the people's changed travel behaviors during the course of the pandemic. Because we would like to explore how this data could be interfaced and fit into the combination of models to model the urban system and the different sectors we are interested, we have identified 4 tools in our study as very helpful. So the first one is the data, and the spatial simulation, the agent-based modeling, and the system dynamics. So the data has been introduced briefly, and then spatial maximization is able to help us to get a synthetic population. It is also able to provide additional information and enriching the microdata and get some very rich information from the new data that we use. The agent-based modeling is built as a structure of driven by the decentralized decisions of individual agents. And instead of assuming a given structure of the system's states and structure could be changed by the interactions with individuals, agents within. The system dynamic models tries to simulate the dynamic behaviors, and it helps us to generate an effective but simplified representation of system behaviors, and normally consists of sets of cause and effect relationships between different elements. So these 4 elements or these 4 tools has their own strengths and weaknesses, and they are listed in here. Firstly, the new data also they provide very rich information about people's behaviors at individual level with high granularity, but they do not provide a complete full coverage. This is where the spatial explanation could come in to fill some gaps in that, and also bringing some more additional characteristics to the microdata. But this does not capture any interactions between individuals. And this time, the ABM could then come in to help. Also, ABM, but ABM is computationally expensive. So we'd like to also take advantage of SD models to help us to run and test different scenarios very quickly. There will also be some like feedback loops between the ABM and the SD to help the combined model to understand and model the interactions at different in the system at different levels and at different scales. Currently, we are trying using the smartphone track and tracing app data with users' consent, and we are trying to build the combined model to understand how incentivizing the reduction of personal car use might impact environment and health. Here are my Twitter and my email. If you have any questions or like to have a chat, please let's get in touch. Thank you.